All right, we're beginning Unit 3 today, and you can see our first section. We're going to be looking at complex numbers. Some of the concepts are going to be review for you in this particular video, but then there's a few new things as well that you haven't seen before. Okay. Notice the objectives. We're simplifying powers of I, we're performing operations with complex numbers, and we're evaluating functions with complex numbers. Okay. Um, so let's start with a review of the imaginary unit I. Recall it's defined to equal the square root of -1. Okay. All right, so we'll fill that in here as well. And recall if I take I and I square it, that means I'm squaring the square root of -1. That's going to result in -1. I cubed would be equivalent to -I. Um, quick little proof to verify that. I cubed could be thought of as I squared times I. And we just got done saying I squared is equal to -1. So -1 times I can be thought of as -I. Okay. I to the fourth is equal to 1. Proof on that. You can think of I to the fourth as I squared times I squared, which is the same as -1 multiplied by -1, which of course would give you 1. Okay. And then I to the fifth would equal, it would simplify back to I. Okay, so recall, these are the four that you really need to know, because after the first four powers on I, everything starts to repeat itself, right? So I is equal to the square root of -1. I squared is -1. I cubed is -I. I to the fourth is 1. Okay. Notice that both I squared and I to the fourth, they actually simplify to real numbers, whereas I and I cubed, they stay imaginary. Okay, so when I is raised to an odd power, it stays imaginary. When I is raised to an even power, it actually simplifies back to a real number of 1 or -1. Okay. All right, so let's use the fact that this pattern repeats itself every four powers of I to simplify I raised to some larger power. Okay, so starting with I to the 31st power, what I'm going to do to reason this out is I'm going to take that power of 31, I'm going to divide it by 4, since the pattern repeats itself every four powers. Okay. So 4 goes into 31 evenly 7 times, right? 7 times 4 is 28, and you'll end up with 3 left over. And the 3 is the important piece here. This means that I to the 31st can simplify to I to the third, which becomes -I in the end, right? Okay. How about I to the 64th? Take 64. Divide that by 4. So first of all, 4 goes into 6 one time. Bring that 4 down. 4 goes into 24 6 times with no remainder. So that means I to the 64th can be simplified to I to the 0 power. And just like any other number raised to the 0 power, that's going to equal 1. Okay. Really, you have a 50-50 shot on these, right? If I is raised to an odd power, it's going to simplify to either I or -I, and if I is raised to an even power, it simplifies to 1 or -1. Okay. All right, so now that we've reviewed imaginary numbers, let's talk about complex numbers a little bit more. So we know a complex number is the sum of a real number and an imaginary number. The sum of a real number and imaginary number. So it typically is going to take on the form of a plus bi, where a is your real number part and b is the imaginary number part. Okay, bi is the imaginary number part. All right, now um, a couple things to really understand here and drive home, okay? So understand that all real numbers are technically part of the complex number system, okay? All real numbers are technically part of the complex number system, all right? So if you look at the tree diagram that I have here, notice at the top you have all numbers, any number that you've ever worked with, and right below that is classified as the complex numbers, okay? And then notice the complex numbers are divided into the reals and the imaginaries, okay? So first thing to kind of draw your attention to is that there's separation between the idea of a complex number and an imaginary number, okay? All imaginary numbers are complex, but not all complex numbers are imaginary, okay? Give you an example of that. Let's take the imaginary number of 2i, right? That's imaginary, and it can also be considered complex if you make a equal to 0 in the value. So 0 plus 2i is, of course, just 2i, right? So that makes it imaginary, okay? On the flip side, what about real numbers? Well, notice this is saying that all real numbers, again, are complex. Think of an example of, 3. That 3 is an integer. It's rational, and it's also a real number then, right? Well, then how can we consider that complex? Because it can be thought of as 3 plus 0i, where it's just the imaginary piece is equivalent to 0i, okay? So that's just, something to, differentiate the idea of a complex number is not the same as an imaginary number, making sure we really understand the difference between the two, okay? All right, so now it is your turn. You're gonna click to practice one, work through those problems really quickly on your own as you pause the video, and then you're gonna come back and check your work with mine. All right, moving forward, this is going to be some of the new material for us that we probably didn't really see too much in our algebra courses, okay? So I want you to understand that you can evaluate a function with an imaginary or complex number just like you would with a real number, okay? So here I have a quadratic function f of x. First thing I want to do is evaluate it with the value of 2i. So that simply means wherever I see x, replace it with 2i, and then I simplify as much as possible. Okay, so 2i, if I raise that to the second power, that's going to become 4i squared. 3 times 2i is going to be 6i. 2 times 4i squared will become 8i squared. Right, and then 8i squared really becomes negative 8 because of the fact that I squared is equivalent to negative 1, right? So now we have some constants here that can combine, and I end up with negative 6 minus 6i. Okay, so notice how evaluating with this imaginary value, it resulted in a complex number for the function. Okay. Let's do the same thing over on the right here, f of 1 plus 2i. So now we're evaluating with a complex number, and same kind of process. This one will be a little bit more involved to simplify. Okay, so recall when you're squaring a binomial, you're going to need it to essentially FOIL, right? 1 plus 2i times 1 plus 2i. That's going to result in a trinomial of 1 plus 4i plus 4i squared. And then I'll distribute this negative 3 here. Okay. I'll distribute this 2. Right, and then I'll clean things up here a bit. So technically, 2, 8i squared, negative 3i, and 2 can all combine together. 2 and 8i squared is going to make negative 6. Then minus 3 would give me negative 9. Negative 9 plus 2 is going to give me negative 7. And then we have two imaginary pieces here. 8i and negative 6i will combine to 2i. All right, so once again, notice evaluating the function result with a complex number results in a complex number. Okay. All right, moving forward, this will definitely be new for the majority of us. Complex numbers can be graphed in a coordinate system, okay? So you're used to graphing in what's known as the coordinate plane that has an x-axis and a y-axis, right? Well, we also have a complex plane, okay, a complex plane. And it looks a lot like a coordinate plane. So notice it does have a horizontal axis and it has a vertical axis. Really the only difference between the complex plane and the coordinate plane is the horizontal axis is now thought of as your real axis, and then the vertical axis is now thought of as your imaginary axis. So notice how the vertical axis has been labeled. It's labeled in terms of I, 2i, 3i, I, negative 2i, negative 3i, okay? So let's say we would like to graph the point of 3i, which is an imaginary number, okay, in the complex plane. It has a real number part of 0, so that means from the origin, you're not going to move left or right at all. You're simply just going to move 3 units up on that imaginary axis. So right here would be 3i, okay? How about 2 plus I? Well, it has an a real piece of 2, so from the origin you're going to go 2 units right on that real axis. And then the imaginary piece is 1i, so you're going to move 1 unit up. It's like you're plotting the point 2, 1 if you were in the coordinate plane. Okay. All right, and then lastly, driving the point home, what if we wanted to plot negative 1 plus 2i? So from the origin, go 1 to the left on the real axis, and then move 2 units up on the imaginary. Right there. Okay. All right, that's it. You try practice 2 problems yourself. Pause the video as you do so. Come back, check your work.